Okay, picture this. It's late at night, you're working on a totally crucial document, and boom, something goes wrong. The familiar file breaks, cracks wide open, and instead of your neatly typed essay, it exposes this hidden, chaotic digital anatomy. Now, usually when a file corrupts, we panic, right? We hit close, our heart rate spikes, and we frantically try to track down a backup. But welcome to this explainer. Today, we're not looking away. Instead, we're gonna put on our digital scrubs, grab a scalpel, and perform a full autopsy on the raw source data of a broken document. We are gonna find out exactly what lives inside the files you use every single day. So, when a file's polished exterior is stripped away, this is exactly what spills out. It's just a string of garbled text. You've got random brackets, scattered letters, weird symbols like FWO, whatever that means, and scattered file paths. To the untrained eye, this literally looks like a completely destroyed document, just absolute digital garbage. It looks like your computer just had a total meltdown. And for years, honestly, that's exactly what I thought it was. But if you look really closely, right in the middle of that sheer chaos, you'll see something highly recognizable: word/document.xml. That little string of text is our first major clue. It tells us that this isn't just random noise. There is a method to this madness. We really have to ask ourselves, is this just a broken file, or are we actually looking at a secret blueprint? Because that chaotic jumble isn't garbage at all. It's the exposed, raw directory structure that holds up every single essay, every corporate report, and every resume you have ever written in your life. When the software that normally reads this file fails to render it properly, it defaults to showing you the underlying code. You are essentially looking at the matrix. You're seeing the actual folders, the structural beams, and the raw scaffolding that tell your computer exactly how to build the document on your screen. You're looking at the architecture of your own work. And this brings us to a massive aha moment. That single polished page you're so used to seeing, the one with crisp text, perfectly adjusted margins, and neatly aligned images, is quite literally an illusion. Under the hood, modern word processing files aren't really single files at all, no way. They are actually neatly packaged, compressed zip folders containing an entire ecosystem of raw text, relationship instructions, and XML codes, all working together in perfect harmony. When you double-click that icon on your desktop, you aren't opening one single thing. You are unzipping a massive, coordinated network of data that reconstructs your document in actual milliseconds. So, how does your computer actually read this blueprint and construct that illusion? Well, it follows a very strict set of instructions, starting with the precise directory paths found in our source data. Step 1. The computer first opens a file called content_types.xml. Think of this as the master inventory list. It explicitly tells the program what kinds of media, fonts, and text are hidden inside this compressed package. Step 2. It checks the .rels folder. Now, rels is just short for relationships. This file acts as the grand map, telling the computer how the different parts of the package connect to each other at a root level. Step 3. It maps word_rels/document.xml.rels, which basically acts as a specific traffic hop, pointing the software exactly to where your images, your hyperlinks, and your paragraphs actually live. Without this step-by-step logic, the software literally wouldn't know where to begin. Now, amidst all this visual chaos and complex relationship mapping, there is one beating heart to your file: word/document.xml. This specific XML file is the vital organ where the actual words of your document live. If you wrote a 10-page essay, pouring your heart out over thousands of words, every single one of those sentences you typed is buried inside this specific piece of code, wrapped up in little tags that separate your paragraphs and lines. It's absolutely fascinating because it separates the actual content from everything else. Without this single file, your document is just an empty shell of formatting instructions with absolutely nothing to say. But of course, raw text just isn't enough, right? We like our documents to look good. We want style, flair, and readability. So how does that raw text get its polished aesthetic wardrobe? Through specific hidden formatting files. Your bold headings and paragraph spacing, that's entirely controlled by styles.xml. The specific color palette and page layout you chose, dictated by theme1.xml. The exact fonts you used are tracked in fonttable.xml, and if you have any bulleted or numbered lists, the software pulls the rules for those right from numbering.xml. You can kind of think of your document as a theater production. Document.xml is the script and the actors, while all these other files are the costume designers, the set decorators, and the lighting crew, just working tirelessly behind the scenes to make the performance flawless. Digging even deeper into this digital anatomy, we uncover the invisible managers, settings.xml, and web settings.xml. Have you ever wondered how a document magically remembers that you like to view it at exactly 120% zoom? Or how it knows the specific print layout margins for your desktop printer, even if you haven't printed it yet? Well, these settings files are the quiet administrators keeping track of your application preferences, your web view layouts, and all your personalized workspace configurations. They ensure that every single time you open the file, whether it's today or 5 years from now, it behaves exactly the way you expect it to, creating a totally seamless user experience. Finally, we reach the metadata, the document's hidden ID card. Files like core.xml and app.xml secretly govern the core properties of your work. Core.xml tracks the really heavy-hitting forensic data, things like who the author is, the exact second the document was created, and when it was last modified. Meanwhile, app.xml records the specific application used to create the file, the number of pages, the word count, and even the exact character count. This is incredibly important because long after you've closed the file, these two XML paths serve as a permanent digital footprint of your work's history. It's the trail of breadcrumbs that digital forensics experts use to verify authenticity or even track down plagiarism. So, knowing everything we've just uncovered, will you ever look at the save button the same way again? We started with what looked like a corrupted, totally unreadable disaster, but by breaking it down and performing this digital autopsy, we've seen that every document you interact with every single day is actually a complex, breathing matrix of hidden XML files, relationship maps, and meticulously organized data folders. It is a true miracle of modern software engineering happening quietly in the background, a symphony of code executing in milliseconds. The next time you hit save on a quick note or a massive career-defining report, just remember the tiny, invisible digital city you are building. Keep exploring the hidden structures all around you because nothing in the digital world is quite as simple as it seems.